Hi there. Today we're going to look at the division algorithm, and what that means, it's really just a method. An algorithm is kind of a rule or a pattern that you would use to take what you learned in elementary school and dividing numbers and try to apply it to something that's more algebraic. So it might be good for us to start back in elementary school and refresh our memory how to do long division, because that's ultimately what we're doing, long division. So let's go back and let's remember, if you're going to take and divide, there's a couple things. Maybe I'll use a couple terms. Maybe I'll kind of refresh your memory on what those are. This right here is your dividend. I remember that because it's inside of the box. So this is your dividend. This is your divisor. And when you divide, the answer that you get up here is your quotient. That's your answer, your quotient. All right, so let's take this dividend of 415. We're going to divide it by this divisor of 8. So to do that, you're going to say, well, 8 doesn't go into 4, but it'll go into 41. So you look at the first two numbers here in this situation. 8 times what would get you close to a 41? Well, 8 times 5. So I put a 5 up here above the 1 to show that 8 goes into 41 5 times. And then I'm going to take that 5, and I'm going to go back and take the 5 times that divisor. So 5 times 8, that's going to be 40, and I put 40 down here. And then you subtract. And 41 minus 40 is just 1. And then you bring your next number down. Is this all coming back to you from 4th grade or whenever that is you learn to do long division? All right, so now you start the process all over again. And you say, okay, 8 goes into 15 how many times? And I would say, well, I could take 8 times 1, but 2 would be too big, so I can have to go with the 1. And then I take my 1, and I'm going to come back and multiply it by that divisor. So 1 times 8 is 8. And then I subtract, and that gets me a 7. 7 is what we call the remainder. And there's a couple things that we can do with that depending on how advanced you were. You would just say that your answer was 51, remainder 7, maybe, when you first learned how to do it. But then later on what we would do is we would take that 7, that remainder, it's 7, and we would place it over whatever your divisor is. So ultimately your best answer for this would be a 51 and 7/8. That's what you would get from dividing those two numbers. Now we're going to do that same thing. That's just numbers. What we're trying to work with is algebra and some algebraic expressions, something that has variables in it. Let's see if we can work through this process and think through it algebraically. I have 4 problems that I'm going to do. If you kind of got the hang of it and you just want to fast forward to one that looks like one that you're struggling with, you can do that, or you can hang with me through all 4 problems. All right, so on this one, this is kind of just the generic basic one right here. It's going to probably be given to you like a fraction, like you're dividing those. Now, one thing that I do notice about this one, and I've thrown a few in here that do this because your homework does as well. Do you see how you have an a cubed, but there's not an a squared? And then suddenly there's just an a to the first and then just a number. We're missing a term in here, this a squared term. Now normally that's not a big deal, but if I'm going to do this division and I line up all these columns and stuff, I'm going to need kind of like a placeholder for my a squared. You'll always want to look at the original problem and see if there's any missing terms, because when you write that, and I'm going to come back and rewrite this and make it look like division, I'm going to write a plus 1 right here, and it's going to divide into, and I'm going to write my a cubed, that's like a 1 a cubed, plus I have to have an a squared, but I can't just throw an a squared randomly in there, so what I throw in there is a 0 a squared. So that's the a squared column, but because it's being multiplied by 0, it really isn't adding anything at all to the problem. And then I can do my plus a to the first power and then my plus 2. This is how I would write that problem. Now I'm going to work through that division algorithm. This is different with algebra because now do you see you have a couple things here? Well, we really just look at the first term, and we're just going to look at this first term. And we say a times what could get me an a cubed? A times a squared is a cubed. So that means up here at the top, I'm going to write a squared. And then just like I did with my numbers, I'm going to take this number that I have up here and I'm going to multiply it by my divisor. But since I have two terms here, I'm actually going to have to like distribute that a squared through both of those. So a squared times a would get me an a cubed. So I will write a cubed and then distribute it to the 1. A squared times 1 is a positive a squared. You see how those a squareds are lining up? We need those to always line up with the matching terms. Now typically what we would do is we would subtract here. And that works okay, but what happens sometimes if we just write subtract, well, we're subtracting everything, not just the a cubed, but also the a squared. So I'm kind of a fan of subtraction, yes, but it's really the same as adding the opposite. And so instead of adding the a squared, it's going to be adding the opposite of a squared. So it's like a negative a squared. Or you might think of it as a negative 1 a squared. Now I combine. What's going to happen every time is this first term is supposed to cancel out. All right, you got the positive a cubed, you got the negative a cubed. And I'm just adding these now. I have a 0 a squared and a negative 1 a squared. That's a negative 1 a squared or a negative a squared. That 1 is really optional there. Okay, once you subtract, you bring the next number down. In this case, that's an a. And we're going to start over. We're going to go back to our divisor up here, and we're going to look just at this first term and say a times what gets me negative a squared. Well, a times a is a squared, but in this case it would have to be a times negative a. Now if I do that right, and I come back and I take this times this whole quantity, I'll take the negative a and distribute it through that. Negative a times a is negative a squared, and then negative a times 1 would be a negative a. Draw your line, and then remember we're going to actually be subtracting these things, and so subtracting is the same as adding the opposite. So I'm just changing all the signs in that bottom row and then just adding together, and you can see here that again, you have a negative a squared and you end up with a positive a squared. Those are going to cancel. That's what I want to have happen. And then I have a positive a with another positive a. Well, that's a 2a. Bring the next number down. All right, looks like we got one more round to go. A times what gets you 2a? A times 2, and it's a positive 2. You have to put a sign there to designate whether it's a positive or if it's a negative. It's a positive 2. So now take that positive 2 and distribute it through the parentheses. You'd have a 2a plus 2. And then you're going to change the signs and combine. So 2a and a negative 2a cancel. A 2 and a negative 2 also cancels. Well, that means I got a 0 left here. Now that always works out nice if you end up with a 0, because that means you don't have any remainder. So your final answer is what you're looking at up here. This right here is what you would type in as your answer. A squared minus a plus 2. No remainder at all to worry about. That's a nice scenario. The main thing to pay attention to on this one is that whole missing a term thing here. If you're missing a term, you've got to stick a 0 as a placeholder so you have a column for those a squareds. All right, that's our first one down. Let's try another one. Okay, this one doesn't look as lengthy, but I do notice that it has an a cubed. So to say it's not lengthy, well, a cubed is kind of a higher power. The a cubed minus 6 is going to go inside the bracket. Now what I have, though, is some missing terms. So I have an a cubed. I don't have an a squared, so I'm going to put plus 0a squared. I don't have an a term. I have to have a power all the way down. So I don't have an a term, so I'm going to add a plus 0a. And then finally I have my minus 6. Out here, is my divisor, a minus 1. Okay, now let's go ahead and start our division process. A times what gets you a cubed? Well, that would be an a squared. Now take your a squared and distribute it through the divisor, so a squared times a squared times a negative 1 would be a negative 1a squared. Draw your line. You're going to subtract, but that really means change the signs and add them together. A cubes are going to cancel. And I have a 0a squared with a positive 1a squared. That's just a 1a squared. I'm going to write just a squared. Bring the next one down. Start the process over. You're looking back up here. A times what gets you a squared? A times a. But you have to put a positive because you do want to keep it positive. Now take that a and distribute it through your divisor. So that's going to be a squared minus a. Draw the line. We're going to subtract, but that really means adding the opposite. A squareds cancel. I have a 0a plus a 1a, and so that's just going to be a 1a. Bring the next number down. Getting the hang of it? All right, so now go back to the beginning here. Take this divisor. A times what gets you a? A times a positive 1. Take that 1 and distribute it. You got a minus 1. And then you're going to subtract, which really means just adding the opposite. So that positive a turns negative, and this negative 1 turns positive. The a's cancel. You have a negative 6 with a positive 1. That would end up getting you a negative 5. Now, I don't have any other numbers to bring down, but more importantly, it has to do with a cannot multiply by something and get you just a number. There would have to be at least an a there. And once you get to that point where you run out of the variable and you're just down to a number, that's how you know you're done. This negative 5, that's my remainder. So I'm ready to write my answer. And this is a little messier to write. My answer is going to be the quotient that I have up here. This is the quotient, so this is my answer, plus the remainder over that divisor. Here I go. I'm going to write as my final answer. What I would type in is a squared plus a plus 1 plus my remainder, which is a negative 5, over my divisor a minus 1. And that's how that would look when you type it in. It's pretty messy. Sometimes you'll see that this negative 5 that I have right here, some people will like to write that as a minus sign. Instead of adding your remainder, you're subtracting your remainder. Now it would only affect the 5, so I'd put a minus sign here and leave that just a regular 5. Don't go changing this sign. This stays exactly the same as it was. But so that I don't mess that up, I usually just leave it as a plus and leave that negative on there. Either way is fine. All right, got 2 more. This one, and what I do on these videos is I usually just pick out problems straight off your practice or off your Certify and try to find a sampling of different types of problems. So this was one when I was scrolling through there, I thought, ooh, that's kind of weird. And it's only weird because they wrote it weird. You can see here that they have this c squared, but they put it after the c term. And down here they have a c, but they put it after their number. You would always need to write this in decreasing order of that exponent. So when I write this out, my divisor is this denominator, so I'm not going to write negative 1 plus 2c. I'm going to write it as a positive 2c and then the negative 1. All right, and inside the bracket there, I want to put the highest power first, so I want that positive 4c squared to go first. And then I would want the negative 2c, and then I'd want the positive 7. You got to make sure those are in the correct order and that you don't have any missing terms, and if you do have missing terms, you got to put that 0 in there to hold that spot. Now that it's set up, I'm ready to go through the process. And this process really is just something you got to practice enough times, it just becomes habit of that. It feels like there's a lot of steps involved. So here I go. I'm going to take my 2c and figure out what do I need to take 2c times to get 4c squared. Well, 2c times 2c would get me 4c squared. Now I'm going to take my 2c, I'm going to distribute it through that entire divisor, so that's going to be a 4c squared minus 2c. Draw my line. I'm going to subtract, which really means adding the opposite. So this positive 4c is going to go negative, and this negative 2c is now positive. And now I just can combine them together, and those will cancel. But oddly, on this one, I have a negative 2c and a positive 2c. Those also are going to cancel. Which means all I have left is this plus 7 to bring down. So I bring down this positive 7. And remember what I said last time. When you get down to just having a number, you can't really take 2c times something and end up losing the c. So that tells me I'm done, and that's my remainder right there. So this one looked kind of messy, but it really came out pretty fast. This is going to be my answer. That's my quotient. Here's my remainder that I write over the divisor. My final answer on this would look like this. I would just have the 2c, that's the quotient, the answer, plus my remainder, and put it over that divisor 2c minus 1. And that is how I would type it in. All right, one last one. This one is a really lengthy one. Not that that makes it necessarily harder, it's just a little bit more details to pay attention to as you go through. I went ahead and wrote it out in this format. It might be given to you like this, or it might be given to you as that fraction, and then you write it like this. I just went ahead and started here. Again, you're only paying attention really to this very first term to decide what to place up here. And then what you place up there will actually get multiplied by all 3 terms. See how there's 3 terms? It's a trinomial this time. All right, so it'll distribute to all 3 of those. So let's decide. M squared times what gets you m cubed? Well, m squared times m would be m cubed. Now you take that m and you distribute it, so that would get you an m cubed. And m times m, that's a negative, actually, negative m squared. If you want to put the 1 there, you can. You don't have to. And then the m times the 3. That'd be a positive 3m. Draw my line, and I'm going to subtract. Subtracting really just means adding the opposite, so my positive goes negative, my negative goes positive, and my positive actually goes back to negative. Always put in the opposite sign there. Now, ideally, that first term cancels. That's what we need to have happen. Now let's see what the rest gets us. We have a negative 4m squared and a positive 1m squared. That'll get you a negative 3m squared. The next term, you have a 6m and a negative 3m. That would get you a positive 3m. Bring your next number down. Now we're ready to start over. We take this m squared and we say, what would we take m squared times to get negative 3m squared? Well, the m squared's already there, so it looks like I just have to take times negative 3. So up here I put negative 3. And then that negative 3 is going to distribute to all 3 of these terms here. So negative 3 times m squared is negative 3m squared. Now take the negative 3 times the negative m. Negative times a negative would be a positive 3m. And then the negative 3 times the positive 3 would be a negative 9. Draw your line. Let's subtract. That negative goes positive. That positive goes negative. That negative goes positive. Let's start combining. The first terms cancel. Oh, looky there. You have a positive 3m and you have a negative 3m. Those are going to cancel. You have a negative 9 and a positive 9. Those are going to cancel. What does that mean? That means I don't have a remainder. And so that's certainly a lot easier to type in for my answer. My answer is just going to be the m minus 3. I don't have a remainder to mess with. I type in m minus 3 and call it good. All right, I hope this tutorial has helped. Good luck.